Here are the solutions to the examples you needed to do for the reteach piece before our projectiles retest. So, again, as with everything that we do online, the best thing for your brain and for your learning is to work the question or attempt to work the question first, and then look at the solution to check your work. If you're just copying down what I'm doing, you're not learning anything, and that's bad. So, for the first one, okay, so for all of these, I want you to box all of the known information, tell me what it is, and then do the guess method to solve the problem. So, here, a ball is thrown straight up into the air with an initial speed of 50 meters per second. So if it's thrown straight up, we're talking about a free fall problem. The acceleration is g, so 10 meters per second squared, down. The initial speed is the 50 meters per second, and I want to know the maximum height. Well, that's the delta y. And if it's talking about maximum height, it tells me that the final velocity is 0. So if we write down all the things that we know, the initial velocity is 50 meters per second up, the acceleration is 10 meters per second squared down, and the final velocity is 0, and I want to know the delta y. Well, the equation that has all that stuff in there is v final squared equals v initial squared plus 2a delta y. 0 squared is equal to 50 squared plus 2 times negative 10 times delta y. So 0 is equal to 2500 minus 20 delta y. We will, in order to solve for delta y, subtract 2500 from each side. So I got negative 2500 is equal to negative 20 delta y. I'm just going to rewrite that, negative 2500, negative 20 delta y. We're going to divide both sides by negative 20. This gets delta y all by itself. Do that in your calculator. Delta y comes out to be 125 meters. How long does it take for the ball to reach its maximum height? So for this, initial velocity is still 50 meters per second up. The acceleration is still negative 10 meters per second squared down. We're still talking about the maximum height, so the final velocity is 0. We know the delta y, it's 125 meters, and we want to know the time. The easiest one to do is that first equation, v final equals v initial plus acceleration times time. So 0 is equal to 50 plus negative 10t. So we have 50 minus 10t. We're going to subtract 50 from both sides. Gets rid of it on the right-hand side. So negative 50 is equal to negative 10t. So negative 50 equals negative 10t. Divide both sides by negative 10. Negative 10's crossed out on the right-hand side, and I get t is equal to 5 seconds. Part C, how long does it take for the ball to return to its initial position? This is different. We are no longer at the maximum height with the initial position. So the initial velocity is still 50 meters per second. The acceleration is still negative 10 meters per second squared down. But because we're talking about the initial position, the delta y has got to be 0. So my delta y is 0. I want how long, that's the time. We can't use anything that we used before because we're at a different spot. So in order to do this, delta y is equal to v initial times time plus 1/2 acceleration times time squared. So 0 is equal to 50 times time plus 1/2 negative 10 times squared. 0 is equal to 50t minus 5t squared. We'll just rewrite that. Now, in order to get t by itself, we're going to subtract 50t from both sides. So I get negative 50t equals negative 5t squared. We'll divide both sides by 5t. Reason being, 5's go away. One of the t's goes away, so on the right-hand side, I'm left with t. Left-hand side, the t's go away. Negative 50 divided by negative 5 is 10. So 10 seconds is equal to our time. Next question. We're going to have to do X and Y column stuff because we're driving off of a cliff. So this is a horizontal projectile thing. So looking at it, a toy car drives off of a 5-meter tall cliff. That's my delta Y, 5 meters tall. With the car driving off the cliff, that tells me the acceleration in the Y is 10 meters per second squared down. The acceleration in the x is 0. There's a projectile going off a cliff. We have no x acceleration. It's just gravity that's pulling us down. The initial velocity in the y direction is 0. That's all the things I know just from it drives off of a cliff. It's a horizontal projectile. Acceleration in the x is 0. Acceleration in the y is 10 down. Initial velocity in the y is 0. And it lands a horizontal distance of 15 meters away. That's our delta x. So we're going to have an x column and a y column. In the x direction, I know the acceleration is 0. In the y direction, I know the acceleration is 10 meters per second squared down. Always. The initial velocity in the y direction is 0 meters per second, and the delta y is 5 meters. Also down. In the x direction, the delta x is 15 meters, and the velocity will be delta x over time. That's how we find velocity. That's what we do when the acceleration is 0. So in order to do this, we're going to find time in the y direction times what I don't know in the y direction. So we're going to use an equation that has all that in there. Delta y is equal to v initial times time plus 1/2 at squared. Plug in all our numbers. So 5 is equal to 0t plus 1/2 at squared, so 1/2 10t squared. So 5 is equal to, well, that 0 goes away, makes that whole term disappear. So 5 is equal to 5t squared. If we divide both sides by 5, we get t squared is equal to 1, or time is equal to 1 second. I found the time. I'm not done. I need to know the initial speed, so I'm going to take that and plug it back in over here. So my velocity is the delta x 15 meters divided by 1 second. And so that velocity is 15 meters per second. This is what I want us to do with horizontal projectile problems. You need an x column, you need a y column, and you need all your knowns in there. And you have to know a good set of these all by themselves, without anyone explicitly telling you what they are. If you cannot do that, it's going to be difficult. All right, last example. Same thing as we did before. We need to identify everything and put it into x and y columns. So cannon fires a projectile with an initial horizontal speed of 200 meters per second. That means the initial velocity is horizontal or in the x direction, and it's 200. The initial velocity in the y direction is 0. That initial velocity in the y direction being 0 is hugely important, and you need to know that when we fire something horizontally. It has no initial y velocity. We're firing from a height of 45 meters. That's my delta y, and I want to know how far, or delta x, away does the projectile land. So, x column and y column. The acceleration in the x direction is 0 always because gravity does not pull in the x direction. The acceleration in the y direction is 10 meters per second squared down. The initial velocity in the y is 0. The initial velocity in the x is 200 meters per second. The delta x is going to be velocity times time. That's what happens when the acceleration is 0. In the y direction, the delta y, in order to find delta x, I need to find the time in the y direction first. So I want to find time in the y direction first. I know my delta y is 45 meters down, and then my time is what we're looking for in the y direction. That's going to be the third equation. Delta y is equal to v0t plus 1/2 at squared. 45 is equal to 0t plus 1/2 times 10t squared. So 45, when the 0 times t part goes away, is equal to 5t squared. Divide both sides by 5. And t squared is 9. Square root both sides. T is 3 seconds. I want to plug that in over here. And my delta x is 200 meters per second times 3 seconds, or 600 meters. This is the last part of the reteach. Remember that this needs to be done before you can take the retest.